Well, now we're going to talk about, well, something we've already talked about, the images of a set under a given function. That's all the elements in the range or the codomain that get mapped to by the elements in that set, by the function. But we're going to introduce now something called an inverse image as well. That's going to be a set in the codomain that, and what it is, the inverse image of that set is all of the elements in the domain that map to a point in that set. So it's a little different than you might suspect. Let's take one of the most simple examples there is. We'll take f of x equals x squared. It's not invertible, is it? It does not have an inverse. But every set will have an inverse image under that function. So for example, I'm going to take a real simple example. Let's say just the number 2 is my set. Well, f of 2 is 4. 2 gets mapped to 4. 4 is the image of 2. What is the inverse image of 4? The inverse image of 4 is every real number that's going to get mapped to 4 under f of x equals x squared. That could be a 2 or a negative 2. So even though f of x equals x squared does not have an inverse function, we can always say there's an inverse image of any given set under the function f. So that's just a little introduction. Here's a formal definition. Images and inverse images. F is a function from A into B, domain to codomain, and P and Q are subsets of A and B. P is a subset of A, Q is a subset of B. And those are the ones we're going to take images and pre-images of. Oh, I'm sorry, images and inverse images of. The image of P under F is just denoted by this. That's how we denote it. And we'll define it down here below. And the inverse image of Q under F, well, we denote that as F inverse of Q. And I'm going to define them here. But before I do, I just want to remind you, this looks like we're talking about F has an inverse. No, all we're saying is that when you take this subset, Q is a subset of B, the codomain, you can take an inverse image of it. It's just telling me every single number that gets mapped to something in Q. So inverse image is not the same as the inverse of a function. And now let's define it. We already know what this is. The image of the set P, P is a subset of A. The image is the set of all the little b's in B such that, the colon is such that, f of A equals B for some A in capital A. So f of P, so we're taking all the numbers in the codomain such that P maps to them. Oops, this should be in P, not A. Because we're talking about the image of P under F. Okay, so hopefully that's clear. The image of P, f of P, is f of all of the points in P. So one more time, it's all of the numbers in B such that f of A is equal to B for all of those values of A that are in P. Okay, now let's go the other direction. The inverse image of Q. Q is in this set, it's a subset of B. So it's going to be elements in A, and it's going to be all of the elements of A such that F of A is an element of Q. Okay, so we're looking at all the elements in Q. Q is a subset of B. What elements in A map to it? And that is the inverse image of Q. Okay, let's do another fairly simple example, but there's a little twist to this one. Okay, F is the function from the real line in the real numbers into the real numbers. Defined, and this is the definition. That's f of x equals 3. So I chose P, the subset of R, to be the interval, closed interval from 0 to 1. And then Q, I just picked one single number, 7. So what is the image of P? Well, it's the image of the interval from 0 to 1. Every single number in here gets mapped to the same number, 3. So this really is supposed to be a set, so I'm going to put it in squiggly brackets. The image of P is the number 3. Technically, it doesn't matter what subset you take of the real line. Whatever that set is, call it S. The image of S is the number 3 because of the function being the constant function 3. Now let's take a look at the other one. What is F inverse of Q? What do you ask yourself? What numbers get mapped to 7? Now here's the tricky part. It doesn't say what numbers in P get mapped to 7. It's what numbers in this set. I'm sorry, what numbers in, let's see, what did I do wrong here? This needs to be 3, I'm so sorry. Nothing gets mapped to 7. So, what numbers in the real line get mapped to 3? And it's all of them. It's the entire real line. So this is equal to F inverse of just the number 3. So that's a set with 3 in it. And that's equal to the entire real line, all of the numbers. Every number in the real line maps to 3. Therefore, the inverse image of the number 3 is all of the real line, or all of the real numbers. Simple example, but it still takes a little bit to digest that. And we'll do some more examples.